Thank you so much for the introduction, and thanks everyone for being here. Unfortunately, I cannot see you, otherwise something will happen with the screen. But thank you, thanks again for, and yeah, I think now there is a black box that you will be seeing. I'm so sorry about that. Right, so as the introduction was quite telling you a lot. One thing is that we changed the title in the meanwhile, so it's data sharing or analytic sharing, and maybe I'll tell you briefly why once we get there. So, but just to start, first of all, let me say that this is again joint work with Bruno, Yassine, and Andrea, and the two of us are the DRC, so we also have to put the fine print that you read down here, and that's it. Okay, so let me get into the talk, and let's say that if there are clarification questions or problems, please do let me know, and otherwise I will I'll keep going, because again I don't see you. Okay. Right, so let's start from our motivation for this work. I wish I could get rid of this thing, 1 second. But okay, let's keep going then. Well, I mean, the motivation for this talk is for our work on this is that, as we all know, I guess this audience is very familiar with that, but generally the data that are generated by all of us and by firms are very valuable, and this value usually goes beyond their immediate economic impact. There is a lot of things that we can learn that can benefit society, and especially in the sector of health. So in a way, this the initial inspiration for this project came from health application, but then we think it's more general than that. And I mean, as we know, firms combine their data for many reasons. The main thing is to get better insights, and there are initiatives that facilitate this exchange of data. So, for example, again, perhaps some of you are more familiar than me with these initiatives, but one very famous one is Gaia X, that want to create data spaces through trusted platforms. And again, the application are many. So data want to be combined from different firms, institutions. Here I have some examples, many in the health sector, as you can see, but many other in other applications, and that's only one screenshot, but you have pages of applications for these kind of things. So that's one example, and then there are others. For example, in the car sector, where again the spirit is to get better insight, better analytics, and gain from the use of data to develop new things and improve products eventually, and find also useful health application that improve our predictions and therapies, for example. And yeah, the main driver of inter-firm data combination is the training of AI models, usually, which again can result in better analytics. So that would be the goal, right? And yeah, in this context, our main principal research question is that how actually we can combine and share data, and what are the different economic implications of these ways, these technologically feasible mechanism. Nowadays, there are many options in which we can combine and share data. And basically, we want to know which one firms, but especially combination platforms, can choose to facilitate firms in those tasks and get better analytics and get to the results that we were discussing about. Okay, so this is our main research question and inspiration. And in particular, giving you a little bit more detail, apologies again for this annoying black thing. Now, so we focus on two classes of data combination mechanisms, basically. The first one, we call it data sharing. Again, one of the reasons of the change in the title is that these are, between inverted commas, explicitly because there are families of technologies and mechanisms to share the data. And we think that these give an idea of what we have in mind, but I will get to some example to make sure we fix ideas, hopefully. And then we will compare these two combination mechanism, data sharing or analytics sharing. So when we talk about data sharing, for example, we can take this example. Suppose we have research teams in a number of hospitals. They have a similar goal, so they want to detect potentially dangerous, birthmarks, skin lesions, and things like that, and they want to combine data to get more precise at this prediction task, right? So they can do what they can do. They can join a platform which offer safe data storage, for example, through some cloud services. So the data can be put on the cloud. And what is really fundamental for us in yellow, in highlighted, is the fact that firms, in this case, will have direct access to this cloud. They can take the data that everybody else has contributed, and they can combine with their own data. So in case of data sharing, the data are put in a, for example, in this example, in a common cloud place, and everybody can bring them home and combine it with all the data they have in their own firm or their own institution. Okay, this is probably the most established practice. I mean, ourselves as researchers as well, we do that in a very simple way sometimes in economics, but we do when we have a common project, we share data this way, and everybody of us can use them and do things with that. But also, this is a clearly common way to do things and move data between firms and institutions. So in this case, there's a lot of data movement in a way. Everybody has to download and bring it on. In our example. Analytics sharing is different. So we thought analytics sharing was giving better the idea compared to the old title. And in this example, for example, we consider farmers that want to combine their data to improve the crop quality. And in order to do that, they have gathered lots of data, lots of things from their activity, but putting them together, they can get more, and so they can join a platform. The platform can access all firms' data, but delivers themselves the tailored analytics to the firms. So in this case, the difference is that the firms do not need to have direct access to the data of other firms. And the platform is running the analytics and trying to extract insights that are, of course, can be different for different firms. The fundamental characteristic from our perspective is that compared to the previous solution where we could use as a firm, from the perspective of a firm, we could combine with the data contributed by others with all our data that we have in-house. In this case, since it's the platform carrying on the analytics, only the data we contributed will basically be used to extract insights, right? So this difference is going to be fundamental from the way we analyze these two mechanisms. And so I hope this example can be, can stay in your mind when I will get to more formal model that we have in a few slides. But but so this is the characteristic, the polar characteristic, and if we want to note something, in a way, this involves less data exchanges. There are less data moving around. And so it has some appealing, these type of technologies and these mechanisms and technologies that are compatible with it, that enable it, are appealing for privacy, security, and maybe also for environmental reasons. That is a debated thing. But there is an interest for this kind of solutions in a way. Okay? Right. So again, this is very important to fix ideas. Now, let me add something. Okay. Well, basically, as I said, there are many technologies, many solutions that are compatible with what we have in mind, with this characteristic that we have in mind for data sharing, which involves, again, having access to all data of others, plus everything we have in-house. And analytics sharing. So here are some examples. I will not spend too much time, and maybe some of the more technical people present are more familiar than myself with such a solution. But these are some of the technologies that can enable or are compatible with one or the other, and basically, our model will be general enough to encompass, apart from our examples, motivating example, this kind of solution, which can enable either data sharing in a more safe way, maybe, or analytics sharing. And in particular, I think something we noticed is that federated learning is a very important technology that is on the rise. There is a lot of interest and investment, and basically, it's one of the maybe solutions that will be particularly prominent going forward in the future. But again, there are many, and potentially our model can speak to the economics incentive to adopt some of these solutions. That's going to be what we do. Again, there is some work also, of course, for those who are interested in the more technical details, some work from colleagues in the JRC that has an overview of this kind of different solutions from a different perspectives. Okay. Now, let me get to the more specific research questions. So again, we look at these two families of mechanisms, and we want to study the incentive of platforms that enables combining data to choose either one, analytic sharing, or data sharing. The second question is then, given the choice of the platform, which mechanisms prompts the firms that are joining the platform to combine, to provide and combine more data with others. And then the third one is about the welfare implication of these activities. So in presence of externalities, which can be positive if we think that contributing data can lead, for example, to find a new vaccine or new cure for some bad disease, or negative if we think that an important characteristic is the danger of leakages, danger of for cybersecurity, for the privacy of individuals. So something that can go beyond the welfare of firms, but spills over to society. And we want to ask under which condition the private choice of a mechanism is also socially optimal from a welfare perspective. Okay? So these are going to be the specific research questions. Now, in our approach, we will have, there's going to be, we talk about data, but there are not going to be actual data. It's a theoretical model in which a platform, as we said, can facilitate that combination by choosing one of the two mechanisms, either data sharing or analytics sharing. And the firms have potentially different data endowments, so our model is compatible with firms of different size, different typology. And they decide to join the platform and how much data to contribute. The main goal and the benefit they will get is to have insights from combining the data with the ones of other firms. And both benefits and costs can be specific to each of type of mechanism and technology adopted. And also, as I said, we will try to study the data generated externalities to see what is the social planner's position with respect to the one of the platform, choice with respect to the one of the platform. Okay, so that's what we do. Let me get you a very small preview of the results. Basically, in case the details are too much to take, so hopefully they will fix ideas. In our first result is that the platform opts for analytic sharing only if it guarantees more efficient analytics, and I will explain exactly what we mean for that. But then data sharing. So there need to be sort of technological advantage of analytic sharing compared to data sharing. And there will be two effects that are important. One is the endowment effect that favors data sharing, and another one is going to be an analytics effect, that favors algorithm sharing. Again, this is, for now, all it's important is that analytic sharing will be better only if it's technically better in a way that I will define soon. Then we find that under some conditions, which we think are fairly intuitive, analytic sharing can lead to more data contribution than data sharing. But it can also go the other way under certain circumstances. So it's not that one dominates the other for sure. But then bringing together the two results, basically because the two results are driven by different factors, then we will see that in presence of externalities, the social planner may not be in agreement with the platform for the choice of the mechanism, either analytic sharing or data sharing. And it will depend on the positive or negative nature of the externalities and the efficiency of the data combination mechanism. So this is the main answers. Now I'll give you more details. Just one very quick slide. I will not spend too much time, but maybe interesting for you to know that there is another paper, economics paper, that is looking at somewhat similar topic, not question. The questions are very different, but basically the paper by Calzolari and co-authors is basically looking at machine data specifically. Ours can be more general, and basically firms need to decide whether they want to combine it or not. The difference is that we consider two, and we try to check what different mechanisms give more or less incentive to combine data or not. So this comparison is sort of new, despite the setting is kind of related. And then there is other streams of economic literature which are not spent so much time, but if you are interested about, we're happy to talk later on, because they're less related to the specific problem that we discuss here. But there is also some more technical literature, again, that some people in the audience may be more familiar than myself, but that compares different technologies and different options to share data or analytics, and our perspective is completely different because it's economics rather than more technical on which technology performs better or not. Okay, so that's all for that, and let me get to a little model. I hope it's I'll try to keep it as intuitive as possible. The model should be simple, because I know that the audience is quite heterogeneous. So basically, in the model, we have three platforms and firms, pretty much. The platform needs to decide between choosing either analytic sharing or data sharing. And what it does, it writes a public personalized contract, one contract per each firm. And this contract specifies a fixed fee, which is basically like what you need to pay once and for all once you enter the platform. So to enter the platform, And this fee can be different depending on which technology is or mechanism is chosen. So either algorithm sharing or data sharing. And then there is a transfer per unit of data contributed. So this can be a subsidy for each unit that the firm contributes to the platform. They will be paid MIT. So in a sense, the platform's profits are quite simple because they will be the sum of all the fixed fees that each firm will be charged, minus what the platform spent to convince them to contribute XI, which will be our measure of data contributed by a firm. Okay? And then there are going to be costs that, again, depend on the mechanism T or technology T, either algorithm sharing or data sharing, and either the operation cost to manage all the data from the perspective of the platform. Okay, I hope it's clear so far. And that's it. So for the platform, now we have also firms. There are N firms potentially, as many as you like. That are potentially heterogeneous in how much data they have. So Y is the data endowment, YI. Now they have to decide whether to join the platform, and if they join the platform, how much data to contribute for combination with the data of other firms that other firms contribute. Now, if they join, they have a data contribution cost, for example, GI, that depends on how many data they will contribute, each of them. And it will depend on the technology or mechanism chosen. What does it imply in terms of profits or payoffs of the firms? Each firm I, under algorithm sharing, will get a benefit from the data. And let me talk a little bit about the benefits in a second. But there is a benefit minus the cost that we just discussed, plus they will get a subsidy or a transfer for the data that they contributed, minus the ticket to enter the platform, right? The one-off payment they have to pay to be part of the platform. The profits under data sharing are very similar. There's a benefit, there's a cost, transfer, and fixed fee. So they look very, very similar. You can appreciate the difference already in the fact that in one, the benefit depends on how much data in algorithm sharing, the benefit depends on how much data the firm contributes and on how much data everybody else has contributed. X minus I is the contribution of all other players that are not I. And in the case of data sharing, instead, what matters is the endowment and of the firm and what everybody else has contributed. Remember our initial example. The key feature of algorithm sharing, of analytics sharing, is that the analytics will be extracted, the insight will be extracted only from the data that are shared with the platform, because the platform will extract the analytics on its own. So the data are put in a safe space by the farmers, and the platform will itself extract insights. So only the data that are provided by firm I will contribute to getting insights. That's why we have XI here, which is the data contribution. Under data sharing, instead, we said that we put everything in the cloud. The hospitals put everything in the cloud. And so they can, one of these hospitals can download the data of everybody else, the data contributors, so the X's of all other hospitals, but they can do the analytics in-house, and as such, they can in-house use all the data, the ones they contributed and also the ones they haven't. So the full data endowment Y is in here. So this is crucial to understand the difference between the two, because otherwise they look very, very similar, right? So the possibility of combining in-house data puts the Y, the full endowment, in the benefits of data sharing. When we share only the analytics, we receive analytics from the platform, then XI, the insights can only be obtained by XI, the data we have contributed, not the full endowment. Okay, so this is crucial, and let me move on. But this is very important to keep in mind for the results going forward. Now, I'll not spend too much time on externalities because they're quite they will be useful later on. But basically, we allow for the total surplus generated by each of the mechanism. We allow for externalities. So the fact that besides the profit of the platform, we also have, and the firms, we also have externalities. So apart from the industry profit, we have the externalities of each generated by each of the technology. The externalities would be due, for example, because shared health data can provide externalities for everybody, not only the hospitals that are working on that, but also we can have negative externalities because, for example, there is going to be data leakages that are hurting everybody, and not only the people, or not only the companies, but also all the people those data are leaked. So we will look at that. We look at the comparison between the two in the last result that I'll show you. Now, the timing of the game that we consider is as follows. So first, the platform chooses the data combining mechanism, which can be analytic sharing or data sharing. Then the platform chooses its contracts. So they choose a fixed fee and a fee for basically a payment for each unit of data contributed, the F and the M, one per each firm. So these are vectors. And then the firm decide whether to join the platform or not. And if they join, then the amount of data they contribute under each scenario, under each mechanism. Now, we have a useful result, which is quite standard economics because of the public personalized contract. The data contribution are such, so the two-part contract with F and M, with a fixed and a per data component, induces data contribution that maximize the industry profits. And as a result, all the profits are fully captured by the platform. So this is a result that is convenient for us, is technical, but it's kind of simple with, basically the firms can be induced to contribute through the subsidy they receive, and then the platform can extract all the surplus they generate, all the joint benefits they generate, net of the cost with the fixed fee. And that allows us to focus our analysis on the platform pretty much, because the platform captures fully the industry profits. So I hope this is intuitive and simple to understand, because then we can move back to the first stage and try to understand which platform, which choice the platform will make between the two mechanisms. And here we need some further simplifying assumption that help us, making the analysis a little bit more easy to understand. So in order to decide which mechanism is more appealing, of course, the platform will compare the profits in equilibrium under data sharing and analytics sharing. that will depend on how much the firms contribute under each technology or in each mechanism. And of course, in the case of data sharing, also on the endowment of the firms, because they can be used to produce analytics in-house. So with this decomposition of, the benefits and the cost of the platform and of the firms, we can compare the profits. And in order to make the results easier to catch, we make one assumption about symmetry. So the first assumption about symmetry is that under both technologies, the benefit function is the same, basically. Of course, what goes in is different, because in one case we know that we can use all the endowment, in the other case not. But the function BI is the same. And the second thing is that the cost of the platforms, we assume for simplicity, again, that can be debatable, but for simplicity, let's assume that it does not depend on the mechanism, okay? And that allows us to, disregard, well, not disregard, but simplify things on this term. But we also allow for some asymmetry. So the asymmetry in this case comes from the costs of the firms. And the cost of the firms are such that the cost of analytics sharing is, of a firm under analytics sharing is GI, whereas the cost under data sharing of the same firm is going to be the same GI, but multiplied by 1 plus beta D. And beta is a parameter that can be positive or negative. If it's positive, let's consider the positive case. It means simply that the cost, basically the relative efficiency of data sharing is lower than analytics sharing. It's more costly for the same unit of data to run data sharing than analytics sharing. So analytics sharing is more efficient, cost efficient than data sharing, if you want to see it one way or the other. So so basically, one possible interpretation we can have is that why would data sharing handling the data be more costly under data sharing than under analytics sharing? Well, it could be because, for example, there is a higher risk, and so the expected cost of data leakages for the firm may be higher with data sharing, given that we said that in those cases there is usually a lot more data transfer, data go around a lot more than if analytics is centralized by the platform in the case of analytics sharing. So, for example, that could be the reason to have beta D positive. Okay, so the rest is symmetric, but costs are higher, potentially higher for the data sharing. Right, so let me get to the result now. The result is, the first result is about mechanism choice. So when we compare these two profits, we can use this decomposition. One decomposition is, the first part is the data endowment effect. So basically the fact that you can use all your Y under data sharing gives an advantage compared to the fact, compared to the situation when you can use only the data that have been contributed by other firms in the mix. And the second effect is what we call a data analytics effect that favors analytics sharing if the data sharing is more costly. So if this beta parameter that we just introduced is the cost is higher for data sharing. And depending on the balance of the two, we can show that basically there exists a threshold for this beta D, above which, so if analytics sharing is sufficiently more efficient or data sharing is less efficient, sufficiently less efficient, then the platform will choose analytics sharing above data sharing. So, and also an interesting characteristic is that given the endowment effect favors data sharing, the higher is the endowments, then the more difficult will be, the higher will need to be the efficiency of analytics sharing to be preferred above data sharing. So this is the first result that we have. Everything is driven by the cost efficiency, eventual cost efficiency of analytics sharing. Okay, but then we have the second result. The second question is which of the two mechanisms drives to more data contributions? And here, technically, it's a little bit less simple to show what is going on. But basically, we can find conditions for which analytics sharing leads to more contribution to data sharing. And this happens if, so these are mathematical conditions. I will probably not spend too much time on definition, but basically the profits need to be supermodular. And whereas the benefit function of firm J needs to be not too supermodular in its argument. Now, basically, the important condition is this one, pretty much. So, in a way, analytics sharing generates more data contribution than data sharing if the benefits function are not too supermodular. What does it mean? The intuition is that the combination of the data does not lead the benefit to increase very, very fast. So if the function were too supermodular, it means that when we increase the data contribution, they grow very, very fast. It's a condition on the second derivative, the cross derivative of the benefit function. And the fact that the benefit do not need to increase too fast, we think it's kind of intuitive in many applications because it's in line with a lot of recent empirical evidence about data combination and about returns to scale and scope in data combination, which, increasing returns, which are sort of similar to the saying that the benefits do not grow too much, are present, but only up to a certain amount of data, and then they sort of stop. So we can think that this is type of studies that intuitively corroborate the fact that probably the benefit function is not too supermodular, or at least after a certain amount of data combined. Yeah, so I think there is also evidence of other situations, depending on the context, that there may be even decreasing returns to scale. So submodularity, which is also consistent with analytics sharing getting to more data being combined. So again, this is the intuition. This is the second result. Now, I will talk to you briefly about welfare now. The thing to notice is that the two results depend on different properties. Like the first result was depending on the technological efficiency of, from the perspective of the firm, of one, the cost basically of one data combination mechanism compared to the other, and in this case, the data contribution depends instead of on the shape of the benefit function, on the properties of the benefit function. Now, when we look at the welfare implication, basically we compare the welfare function that I briefly introduced before, basically maybe the easiest way to see what is going on when we try to understand the welfare effect is that we can start from a situation where data sharing, for example, is preferred by the platform over algorithm sharing because, for example, the profits, the profits of data sharing are higher because it's sufficiently efficient. The beta is below the threshold that we talked about just before. In this case, well, there is this effect, which is positive because data sharing is better, but there is also a possible data breach, which has negative effects for society. Then, maybe if algorithm sharing, analytics sharing leads to more contribution, more X's, it's possible that, this part, this negative part is going to be high because a lot of data are combined with analytics sharing, and well, that could be bad for society, right? Because there's more data that are leaked if that leakage takes place. So then we can further decompose these, sum of this difference of welfare of total surpluses. And we have a first part where basically I added and subtracted this term here. And so beside the profit effect, which we said is in favor of data sharing, well, we can have a technological effect here because we know that, for example, in this case, supposedly algorithm sharing, analytic sharing will lead to more externalities, as we were saying. But there is also a data contribution effects that depends on the fact that the two, even if we fix the same externality function, the two lead to different amounts of data being shared. And in this case, then in the case of a negative externality, this would favor data sharing, could be better than analytic sharing. So there are three components, and basically this data contribution effect is something that may go beyond the technological aptness of one of the two in terms of externalities. Now, maybe in order to fix further to navigate a little bit further the welfare effects, we basically sort of shut down one of these two effects. So from a technological viewpoint, we think that they lead to the same externality. We make a further assumption, and still we can see that the data effects can lead to different choices in terms of total surplus, can lead to a different choice compared to what the platform would choose. Let me explain this through, and this is probably going to be one of the last things that I want to tell you, through the graph. So in this graph, we have externalities, which can be positive or negative on the y-axis, the vertical axis. And we have the relative technological efficiency of analytic sharing compared to data sharing on in here, which is the beta d. Now, if you remember, if beta t is sufficiently high, so analytic sharing is very efficient, then the platforms want to select analytic sharing. Instead, if it's low, and basically data sharing is not so bad compared in terms of cost, then the platform selects data sharing. And so we have this vertical line that separates the two parts of the diagram. Now, because of what we said about the externality, so one of the two leads to more externalities because of the quantity effect, despite at the same level they would lead to the same. There's no technological difference in the externalities, but it's only driven by quantities. Still, we can see that there are situations in which basically because of what we said about the fact that it's not beta d is not influencing directly the contribution, then we can have a situation in which, for example, if the platform select data sharing because it's relatively efficient, but there is a strong positive externality and analytic sharing leads to a lot more contribution, then maybe the social planner would like to be here and would like to have analytic sharing because the externalities are very, very high. And so there would be this preference, and there is a discrepancy between the choice of the platform compared to the choice of the planner. So there is these possibilities. There is a possibility, similar possibility in case of negative externalities. And so basically, we need to make sure that when there is this misalignment, something is done because some potentially important benefits, social benefits, may not be, materializing because of the choice of the platform. And so this is an important message. Just one quick thing to conclude. We have some extension because our basic model that I just presented you is very based on many simplified assumptions. So extension that have to do with secrecy, the fact that firms may appreciate secrecy, so the contracts may not be public. And that can be achieved in different ways. So we have a couple of extensions. And for both, we checked whether the secrecy favors one or the two mechanisms compared to our baseline model. And then we have different type of data leakages that basically we dig in further types of externalities that affect that affect one mechanism more than the other. So we relax the fact that the externality function is the same as in the graph, and also we consider the effect of data leakages affecting first profits differently in different scenarios. And so that's it. We have some tentative policy discussion, which again has to do with the fact that especially there may be a discrepancy between what is socially optimal and the socially optimal mechanism and the one that is instead chosen by the platform. One thing that I would like to say before concluding is the fact that we want to say that we look at the pure incentive to choose one mechanism on the basis of sharing data for collaborative projects that can lead to or projects that can lead to analytics and benefits. We didn't look at any competitive effect, either competition between firms. So hospitals want all to go in the same direction. They do not compete for patients. And we have not looked at the competition between platforms or this kind of situation, because this may completely change the analysis and the effect that we find. So pretty much these are very interesting topics, but we have not touched upon. So the desirability of analytic sharing or data sharing depends on the context, and these contexts are not present in our analysis. And with this caution word, I will basically finish, and I hope you got part of the message. Basically, we try to study the effects of analytic sharing and data sharing, and what are the economics incentive to choose one or the other. That's all.